Okay, let's get underway. And it seems to me, studying the whole of the program of ARC 2018, that this session will be the most specialized of all, because out of the 8 speakers we have, 7 are doctors and the other one is a professor. And what we're talking about here is we're going to break the session down into 2. The first will be the issue of gene doping, and then we'll go on to veterinary regulation. And to introduce the first speaker for gene doping, I'd like to invite Dr. Makoto Inoue onto the stage. Dr. Inoue is Presidential Counselor for International Affairs at the Japan Racing Association. He will also formally be the chair of this session. Inoue-san.
Good morning, ladies and gentlemen. Welcome to the gene doping session. As you may recall, the gene doping was raised at the previous ARC in 2016 in Mumbai. Anti-doping is one of the fundamental issues in horse racing. It is very important from the aspect of horse welfare, integrity, and fairness, and the protection of the thoroughbred breed. The threat of gene doping is not well recognized to the racing industry. The object of the session is to cover the regulatory approach of gene doping to understand the current state of gene doping control and various detection methods which are and will be available. Let me introduce the 3 speakers that we have invited. The first speaker is Dr. Kanichi Kusano. Dr. Kusano is a regulatory vet as well as a surgeon in JRA for more than 20 years. He is the chair of IFHA gene doping control subcommittees. He's a nice guy. My colleague. The second speaker is Dr. Natasha Hamilton. Dr. Hamilton is the director of the newly established Racing Australia Equine Genetic Research Center. She has a PhD in equine genetics and is also a member of the International Equine Gene Mapping Group and the International Society of Animal Genetics. The third speaker is Dr. Teruaki Tozaki. Dr. Tozaki has 2 PhDs in both pharmaceutical sciences and animal genetics. He works as a senior scientist at the Laboratory of Racing Chemistry and is currently working on the project to develop detection methods for gene doping, which is granted by the JRA. He likes alcohol. And he likes ladies and gentlemen, before we carry on, please be noted that we do not have time for questions. Speakers from this session will be available during this conference, so please feel free to approach them if you have any question. Everyone, please welcome Dr. Kusano.
Thank you very much for the kind introduction, Dr. Inoue. I'm not sure whether I'm a nice guy, but it made me feel really relaxed after that comment. So for today, I'm going to make a very short presentation as an appetizer for the following 2 speakers. I'm going to talk about some general information about what gene doping is and what's the impact for the racing industry. And the second one is the role of the IFHA Gene Doping Control Subcommittee. And I would like to finalize my presentation by suggesting some practical but very simple and short ideas that you can take home and put it in direct action. So I'd like to start with this slide, why are we so concerned about gene doping? The answer to that is very simple. It's just the trend of times. This slide is the transition of drug development. And as you can see, we started from the mold in a cheese. And after that, most of the drug is made from compounds. And now, like from early 2000, some therapies has used DNAs. So it's very natural for us to be facing the risk of gene doping, because if the definition of doping is the misuse of therapeutic drugs, we have DNAs for therapeutic drugs. That's why we are facing gene doping. And what I have to emphasize here is that, as you can see, because for the long time, compounds have dominated the drugs. Many works that we have done for the doping test analysis is focusing on compounds. So that's why we need new experts, we need new instruments, so that we could tackle this from a molecular genetics side. So that's why we have to be careful when we deal with DNAs. We have to have new people and new instruments. So I'd like to simply introduce why is gene doping a risk in the racing. I'm not going into the details because these two will be very good at explaining the precise of them. So when I talk about gene doping, I will start from explaining gene therapy, because gene doping is an abuse of gene therapy. So there are two important items in the gene therapy, which are transgene and gene editing. Don't worry, you understand with the next people. So the risk of gene doping from these two items of gene therapy is that it will damage the integrity of the sport and racing, which is pretty much common for the previous drugs. Another one is the gene editing, which is a bit problematic, a little bit nasty, because if gene editing is abused, we have a great risk of creating a genetically modified thoroughbred, which will infringe the definition of thoroughbreds that we have this is a really basic part of racing. So if you don't have thoroughbreds, that's a great risk for the racing industry. So the task, that from this background, this is why the IFHA created a subcommittee under the IFHA EXCO, which is also our subcommittee is composed under the Advisory Council of Equine Prohibited Substances and Practices. So I'm working in this part, which is also in a power of IFHA EXCO. So our subcommittee was established in 2016, and I've already explained the backgrounds. We currently have 10 members from various jurisdictions and various expertise. So if you have any problems, please feel free to approach these 10 people. We will try our best to help. And our mission statement is to advise racing and breeding authorities on the regulations of gene therapies and to assist in the formulation of strategies and guidelines to prevent the misuse of such therapies. Terms of reference: to safeguard the integrity of horse racing and thoroughbred breed by evaluating genetic and cellular therapies with respect to potential welfare, safety, performance, and breeding effects. So what we particularly do is we will try to define what gene or cellular doping therapy is, and to make clear which gene or cellular therapy practice have no place in horse racing and breeding, and we will try to provide guidance for the proper control of legitimate use of genes and cells. And we also work to suggest revisions to Articles 6, 12, 13 in the international agreement. So I'd like to introduce the latest update of the Article 6b in the international agreement, which is focusing on gene doping. So we have completely revised this 6b to focus on what gene therapies are, because gene doping is simply the abuse of gene therapy. So the definition of genetic therapies are to administer oligomers or polymers of nucleic acid and their analogs, and genetically modified or modified cells. But don't worry if you don't understand them. They will explain. And regarding the really nasty, the bad creature about the gene editing is under process, so we hope that we could address our draft later this year for the new suggestions to the international agreement. So we're pretty much working in a good time frame, so I hope you understand what we are doing to assist the industry. So this is my last slide. It's a take-home message. What you should do when you go back to your own jurisdiction. You should first strengthen your rules of racing or relevant rules to focus on anti-gene doping. So simply you can refer to Article 6b of International Agreement. And I think you also need to improve your testing system for gene doping. So what I suggest is simply when you go back, just talk with your staff in your lab, whether they are ready to do a research or they're ready to conduct actual doping test, so that you would know if you have appropriate experts or equipment in your lab. Also, if they don't, you will have to maybe support them financially. But if you don't kick off, it'll be quite difficult for the labs to upgrade themselves without being told. So I think this is what you can do when you go back. And the vets are particularly important when you do doping control. So education for veterinarians, of course for trainers and stable staffs are important, but for veterinarians, if you simply ask them, do you know transgene or gene editing, what's the impact for the racehorse industry? If they couldn't answer that, it means it's an alert. So please send them to some kind of, we have good meetings called ICRAB, which we focus on doping issues and welfare issues. It is an international conference once in 2 years. So this is what you can do. So I'd like to roll up my presentation by asking all of you that if you need help, we are always happy to help. So please approach us whenever necessary. Thank you so much.
Our next speaker is Dr. Natasha Hamilton. Dr. Hamilton is Director of Racing Australia's Equine Genetics Research Laboratory in Scone, or Scone?
Scone.
In Scone, New South Wales in Australia. A world's first test to detect gene doping in horses.
Thank you very much. So I do want to reiterate that, yes, we are very happy to help you, but I also like alcohol. So if you would like me to answer one of your questions later, you may want to bring a drink. So thank you very much for the invitation to present here. I'm very excited to talk to you today about our test that we have developed to detect horse gene doping. And I am going to have to start with just a little bit of a refresher course in genetics. And this is for those of you who were at the races that day. They taught this at school. So just to remind you all, our bodies and the bodies of all living things are made up of cells, and DNA is just a protein that exists in the cell. And the DNA is created from repeats of 4 different subunits called C, A, G, and T. That's just how we refer to them. So when anyone talks to you about a DNA sequence, what they're actually referring to is the order of these bases along the chromosome. And then a gene is just a piece of DNA that is used to create a protein. So it's a functional part of the DNA. So I'm going to just explain a little bit about gene therapy. I suspect you already have probably quite a good idea of what this is about. And I'm really going to focus on the gene transfer part of therapy. Dr. Tozaki will talk about gene editing after me. So the idea of doing gene therapy is that you have an animal that is sick or has an injury. So the example I have here is a horse with a bowed tendon. Now, tendons are quite difficult to heal because they don't get a good blood supply. So often they need rest and they need rehabilitation, and often different therapies are applied by veterinarians. So this might be the injection of some growth factors or proteins that help to reduce inflammation or that help to improve blood flow. However, with these proteins, they tend to be broken down quite quickly. So the idea of using gene therapy is that you insert the gene, and then the gene will go into the cell and produce a longer lasting protein supply for that tendon to help it to heal better. And ideally, you end up with a lovely, healthy leg. What the aim of our gene doping subcommittee, gene doping control subcommittee is to prevent these therapies, these legitimate therapies, from being used to help people win more races. So the number one comment that I get is, do we really need to worry about this? This is pretty high science fiction type of stuff. I don't think this is ever going to happen. And we've had a beautiful introduction to this morning. I have to thank the 2 Jacks for their introduction into doping issues that we have had recently. You have already seen some headlines such as these. These are real headlines from Australia. And after these stories broke, there was a drop in the wagering levels in the few weeks following these stories. There are anecdotal stories of people trying to get new owners into racing, and the owners, they're finding it harder to get owners because they are worried about the integrity of racing. But the real issue, which was beautifully portrayed this morning, is that public perception. So I work in a genetics laboratory. I ring up suppliers to order goods, and I have complete strangers, salespeople, saying to me, "You work in the racing industry? Isn't that all really dirty? Why do you want to do that?" So the question is not, do we really need to worry? It is, can we afford not to worry about this? We need to make sure this absolutely never happens. And I'm glad to say that these are not real headlines. I have made these ones up. But you can just imagine the field day that the media might have with what they might think of as genetically modified horses or Frankenstein horses. So we really need to make sure this absolutely never happens. And I'm really, really pleased to have been involved with this project, which was initiated through Racing Australia and Racing New South Wales when I used to work at the University of Sydney. So I'm going to now just tell you a little bit about how that project has evolved, how we've gone about creating this test that can detect gene transfer. So because we are looking at gene transfer, we had to predict what types of genes people might put into their horses to try and enhance performance. And we used 3 sort of criteria for this. So the first criteria with the horse at the bottom there, we looked at what genes had already been used for gene therapy, and we included humans in this, but also particularly focused on the horse. We also considered drugs that are already used in their protein form, so your normal drugs that we test for for doping control. And then finally, we also considered genes that are known or suspected to have an impact on racing performance in horses. So I'm just going to explain these in a little bit more detail as to how we came up with which genes we would target in this round of tests. So this is just a table showing just a very quick snapshot of some of the current horse gene therapy studies that are being carried out at the moment. And I'm not going to go into that in any detail. I'm just going to highlight that the two studies at the top have VEGF. So these are growth factors, these two genes. What those genes do is they encourage the growth of blood vessels to a particular region. So as you can see, that would be very helpful if you have a horse with a tendon injury. You'll see the word IGF-1. IGF-1 is very well known for anabolic effects, so it's a sort of fairly obvious target. It helps to strengthen muscle. And then the interleukin-1 receptor antagonist, or IL-1RN, that's an anti-inflammatory gene. So that gene actually helps to reduce the inflammatory effect. So they're the sorts of genes that are being used for gene therapy, gene transfer. And as you can imagine, they might also be helpful for performance. So our second criteria were drugs that might be used for performance, for doping in performance normally. So I actually just Googled human performance drugs, and this came up. I apologize, it's a little bit fuzzy. And there is a little bit of overlap, but really for the horses, I think the sort of gene or the substances you might see are your things like your non-steroidal anti-inflammatories and corticosteroids. So these are the substances that you tend to see used on horses, and we get occasional positives for. And certainly genes that not only encode these drugs or mimic their effects would be targets as well. And then finally, our list was to look for genes that were associated with performance. And I've been very careful to not incriminate anyone and pick an obvious non-racehorse here. But these are sort of groups of genes that we know they certainly have some effect on performance in other species and may do in horses as well. So for example, in the pain perception and injury repair type genes, these are the ones that help with reducing the effect of pain, and they're anti-inflammatory genes as well. We also have a list of genes there that are involved in building muscle strength, so obviously would make a horse more powerful. Angiogenesis, that's our growth factors again. That's to do with that delivery of blood. And then, of course, when you're delivering blood, what you're really doing is delivering oxygen. So we have our oxygen regulation genes there as well. And then the group at the bottom called for energy metabolism, I'm going to just describe a couple of those. So these are the genes that help break down stored energy and make it available for muscles to use. So PPR delta was one, so scientists were studying this gene, so they injected it into some normal mice, and they found that these mice could run about 1.6 kilometers compared to normal mice that could run 800 meters. So this sort of doubled their endurance ability. This all pales into insignificance when you consider the PEPCK mice, who can run 6 kilometers. We're just going to think about this for a second. These mice can run 5.9 kilometers further than I can. So that's really quite impressive. And you can imagine that when these studies came out, there were a lot of football coaches and there were a couple of horse trainers that contacted the scientists and said, "When's this available? I think my horse needs it." So obviously these genes are of interest. I'm just going to highlight very quickly, these are the genes that we also mentioned in the gene therapy that are being used for gene therapy. These are genes that are involved with producing a protein that mimics the action of a normal drug. And I'm going to just give a special mention to myostatin, which is really the only gene that has been unequivocally shown to be involved in racing performance. Next to that, you'll see a picture of a whippet. This is a whippet with a naturally occurring variant of the myostatin gene, and it has no functional myostatin. And you can see it's a very big dog. There are similar variants in the horse, but they have a much more subtle effect. So it just gets its own special mention. So I'm just very briefly going to describe how our test will work. how our test works. And first of all, I have to talk about how genes work. So the genes are just sitting along the DNA. They're not really doing anything until something triggers them to start working. So they'll get this trigger to go, and the first thing they will do is make a copy of themselves out of a very similar but not the same molecule called RNA. And then you'll notice on the picture that the genes, the part that makes protein is not continuous. It's interspersed with bits that are not used to make protein. So the next part of the process is to chop those bits out. So you get what's called mRNA, which creates the template from which the protein is created. So our test really focuses on that process of splicing out that unused DNA. So when you do a gene transfer, you generally can't insert a whole gene because they're quite big. So what people do is they chop out those bits that aren't used for protein. So the inserted gene is smaller than the normal DNA. So they'll end up inserting a piece of DNA that looks like that, and what that does is it creates very unique sequences at the spots where the bits have been chopped out. And those unique sequences are what we target with our test. And now we use a very simple or a very commonly used genetic technique called PCR. And it's late in the afternoon, so I'm not going to explain to you what PCR is at risk of you all falling into sleep. But it's a very commonly used procedure. So we have been developing this test, me meaning my PhD student, has been developing this test for the past couple of years. And the test can currently detect 10 copies of the inserted gene in the reaction mixture. So if we take a blood sample and we spike 10 copies into that blood sample, it can detect that very easily. It screens for 5 genes in 2 separate reactions. We were aiming to have 5 genes in one reaction, but it didn't work that well. This has doubled the cost of the test, but luckily the test is not expensive anyway. So it costs less than $40 Australian, which is about $2 American, to run, no, I'm joking, to run the test. And it takes about a day to process. We have performed some surveillance testing just to sort of test the waters over the Sydney Autumn Carnival earlier this year. And of course, this test is relevant. We've designed the test so it's relevant to all breeds of horse. So it could be used for other horse sporting pursuits. So the examples here are trotting and pacing races for the Olympics and for endurance races in particular. So for me, this is super exciting that we've developed this test. We're planning to use it next year in real life. But what that also means is we're starting to plan the next suite of tests, what we're going to do next. This only detects the gene transfer that I've been talking about. It doesn't detect gene editing, so Dr. Tozaki is going to talk to you about that. And it really highlights that complementary methods will be needed. We need to have lots of different ways to track how this might happen. And I think, again, this morning in the integrity session, it really highlighted how important intelligence is as well, so for strategic use of this test. And regulation is very important, which goes back to the role of the IFHA and the actual rules there, and how we frame those rules are very important to how we might be able to prevent this from happening. We do not want to ever get a positive to this test. And I just want to finalize by thanking my team. Any researcher, any good research comes from a team. Dr. Adam Cawley is the current project leader from Racing Australia and Racing New South Wales. I'll be transitioning into that role soon. Dr. Craig Sewan, that we have also from Racing New South Wales. We have a team from the National Measurement Institute in Australia, and they have worked on gene doping detection in humans, so that was a really lovely fit. And I have to make a particular mention to Miss Tessa Wilkin, who actually did all the hard work. She's the one that's been sitting in the lab, so thank you very much.
Thank you, Dr. Hamilton. The doctor has already introduced the next speaker, and here he is. He is Dr. Terua Akitozaki, who's technical advisor at Japan's Laboratory of Racing Chemistry. And there is the title of your presentation, yep. Doctor.
Mr. Chairman, thank you for inviting me to speak at this plenary session, as well as your kind introduction. I also think that you also like a lot of, drink a lot. My name is Terua Akitozaki, and I'm a senior scientist at the Laboratory of Racing Chemistry. Our institute undertakes all the doping and parentage tests for Japan. Dr. Kusano introduced the transgene and genome editing of gene doping issues from the point of view of regulatory science. And then Dr. Hamilton summarizes the benefits and the risks of transgene and its detection method. Therefore, I will focus on genome editing, which may soon become the most serious concern in horse racing industry. Today, my presentation will be on the definition, threat, and regulation of genome editing, as well as on its detections. So first, I ask everyone here, have you heard these items listed on this slide? Hornless dairy calves, pigs with natural protection of infections, tomatoes that don't need pollinating to produce fruits, mushrooms that won't go brown, wine that doesn't cause a hangover. This is very nice, I think. Please raise your hand if you know any of these. Anyone? Oh, thank you very much. There appear to be some in the audience who know about some of these items. The items listed in this slide are all genetically modified organisms that have been produced by genome editing. Even while I'm talking now, a number of genetically modified animals are being produced worldwide with the help of genome editing. Next, I wish to elaborate on genome editing. As shown in the slide, genome editing is a type of genetic engineering in which DNA is inserted, deleted, modified, or replaced in the genome of the living organism. Since the development of CRISPR technology in 2012, research with respect to genome editing has exponentially increased and resulted in the progress of applied research in various fields, such as human medicine, veterinary medicine, and agricultural science. I believe that genome editing and its industrial applications can no longer be stopped. Has anyone seen the YouTube video pictures in this slide? Do you know what he's doing? He made a do-it-yourself DIY gene therapy drug, which he then injected into himself. Dr. Zaina, who is shown in this video, has a doctorate in the field of biology. Therefore, he has a lot of knowledge in genome editing and gene therapy. Nevertheless, this is still a very dangerous undertaking. As expected, the US regulatory authorities have issued a statement regarding this. What I would like to highlight here is that genome editing may already be a very familiar technique that can change our lifestyle, as well as gene doping in sports and racing industries. I obtained the image and the text for the slide from the Odin company website in the US. Odin sells the genome editing kit on the internet to general consumers, and these kits priced at only $159 US. Although it is difficult to prepare genome editing therapeutic drugs with this kit, I believe that it is possible to easily perform genome editing by non-experts. When looking at the comments associated with this kit, surprisingly, high school students are included in the users. I feel that genome editing has already become an ordinary science rather than power of God. Many of you, the audience, might think that genome editing has not yet been applied in horses. However, according to the Daily Telegraph on last December, genome editing has been performed in horses by Argentinian scientists. And by next year, it has been estimated that genetically modified horses will be born. The scientists modify the myostatin gene to produce a super horse that has improved the jumping power and can run faster. Therefore, genome editing is a technique that is applicable for use in horses. Is genome editing regulated in the horse racing industry? The answer is both yes and no. This slide shows the regulation of World Anti-Doping Agency, WADA, and the International Federation of Horse Racing Authority, IFHA. Similar to the WADA code, genetically modified race horses are already prohibited under Article 12 of International Agreement of Breeding, Racing, and Wagering, IABRW. Because modification of heritable genome is prohibited. However, genome editing in postnatal horses is not yet clearly regulated. For this reason, the IABRW needs to be revised to include genome editing within its guideline as soon as possible. The Gene Doping Control Subcommittee, IFHA, is now discussing this. Now, we can discuss how genome editing can be detected. In the present scenario, it's important to collect and store the blood sample of all race horses as a deterrent. In doing so, the blood sample of a racehorse suspected of genome editing can be analyzed via detection method developed in the future. Some European countries seem to have planned collecting and storing blood samples specifically for this purpose. Next, I will talk about the potential genome editing detection method that we will be able to use in the near future. Currently, my laboratory work focuses on the development of a method for detecting genetically modified horses, undertaken with the help of a research grant from the Japan Racing Association. The technique we utilize is whole genome sequencing. Although the whole genome information is enormous, we can theoretically detect modified genomic regions by comparing the entire genomic information. In other words, parent-whole DNA comparisons carried out during racehorse registration will be performed at the whole genome level. Furthermore, comparing individual samples before and after they become racehorses can be useful in detecting genome editing in postnatal horses. Lastly, I suggest achievement of the point shown on the slide. First, it is important to include genome editing as a prohibited matter in our legislation. Second, there is a requirement for investment by racing authority for gene doping control. There is a great need for extra-human resources such as molecular geneticists, biologists, bioinformaticians, as well as investment in new facilities such as next-generation sequencers for gene doping control. Further research funds are also required to continue work on genome editing and gene doping issues. After you all return to your respective countries, please visit and check out your doping laboratories. If you have any queries related to preparation of a new laboratory to test for gene doping, I invite you to please visit our laboratory in Japan. Lastly, does anyone here know about the Japan World Cup? This is not to be confused with the Japan Cup. The Japan World Cup is a horse racing game on the internet. This game was developed for promotion of Japanese horse racing to motivate younger generations. One of the interesting aspects of the game is that each racehorse may not necessarily be a horse. Some competitors are horses with long bodies, whereas others are horses that look like elephant or giant pandas. Those animals may be produced over genome editing. Anyway, this is a very interesting concept for a game. But not everyone here would want such a horse race to exist. However, if nothing is done about genome editing, this might occur in the real world in the future. Thank you for your attention.
Dr. Tozaki, thank you very much indeed. And Dr. Inoue, if I can invite you to the podium to make a closing statement for this panel.
Thank you all for the good presentation. Ladies and gentlemen, I hope you all enjoyed this very interesting and thought-provoking presentation. I'm sure you will agree that the ARF and the global racing industries generally are lucky to have such knowledgeable specialists. To summarize this session, we should acknowledge that gene doping is not a rumor. The abuse of gene therapies and gene editing can lead to the collapse of racing industry by destroying the definition of the thoroughbred and by undermining the integrity of our races. Therefore, we racing authorities must play out with our full might to tackle this issue. Although current science is not perfect and cannot control all the doping against and techniques, there are certainly some steps that the racing authority can start with. I would like to close my session by suggesting you to act for the legislation of gene doping in your jurisdiction, communicate with your lab, and provide proper support to them. Lastly, do not forget to educate your regulatory staff. Thank you very much for your attention.
Doctors, thank you very much indeed. Okay, as we swap panels, because now we're going to have one on veterinary regulation, I'd just like to tell you something that just appeared on the Reuters Twitter timeline at 3:24 this afternoon. Now, if you work with horses, you'll probably tell me that you know this already, but there's been some research released. The research comes from Professor Karen McComb from the University of Sussex in England and Dr. Leanne Proops from the University of Portsmouth. Please come to the stage. Okay, so thank you very much indeed, doctors. We're going to swap. We have 4 for 4, so that's perfect. Thank you. These two doctors have been showing horses photographs of people smiling or frowning. 4 to 6 hours later, they presented those actual people to the horse, and the horse has reacted negatively to the photograph of the person who was smiling and has reacted positively to the person, the other way around, of course, has reacted negatively to the person who was frowning and positively to the person who was smiling. And these two doctors say that it shows and it proves scientifically that horses have a higher emotional radar than many people think. And as I say, you probably working with horses know that already, but most people don't. That just appeared at 3:24. If you look at Reuters Top News on Twitter, you'll see the short video of that research. Okay, so this is the final panel of the day, and it is veterinary regulation, and I'm going to leave you in the very capable hands of Dr. Brian Stewart. Dr. Stewart is head of veterinary regulation, welfare and biosecurity policy at the Hong Kong Jockey Club, and you are going to be in control, so I'm going to leave it all to you.
No, thank you very much. Thank you. This session is going to focus on how science can help veterinary regulators do a better job. One of our main tasks in regulation is to protect the the safety and the welfare of horses and also of jockeys. And we have struggled, I think, to some extent over the years to improve our performance. We're at a plateau. Advanced organisations like Hong Kong or Racing Victoria, where I recently worked, have good systems. They have very good people doing a good job, but we've effectively reached a plateau of improvement, and we really seek that continuous improvement to do our job better. Now, to do that, I think we have to look to science. We have to look at understanding the nature of the problems we face better. We have to look at obtaining evidence that we can base our initiatives on, and if we're going to change rules and regulations, we need to have evidence to support those changes, that they're rational and that they are based on sound science. Racing injuries, I've been doing pre-race veterinary inspections and various systems to try and reduce injuries in horses for a very long time. And one of the most frustrating things is that when horses suffer fatal fractures in racing, we know that they go into that race with a pre-existing problem that almost preordains that that fracture will occur, but we can't detect it, and we don't have the tools to do that. And if we look at our fatal injury rates over, well, my career, which is perhaps 30 years, we haven't really made a significant difference in the rate of injury. So we need to make, to use a cliche, a quantum leap in how we achieve things, or how we regulate to reduce that rate of injury, and how to better look after our athletes and our jockeys in racing. So science will be the way forward. Maybe we will only achieve incremental improvement, but any improvement is welcome. And today we have two preeminent scientists who are working on this area. They are world class, and I'm very pleased that we're getting an opportunity to bring their work to a wider audience beyond the veterinary area. It is a pleasure to have them here, and I think you will find their presentations fascinating. We also have a Korean Racing Association veterinarian who's going to tell us how the Korean Racing Association has approached the problem and tried to improve that safety and welfare. One other point I would like to make is that if we can reduce injury in horses, especially conditions like osteoarthritis and subchondral bone issues, we are going to have horses that are going to go out of racing in much better condition and in a much more suitable condition to undertake future careers and to have a comfortable and ongoing retirement. Horses going out of racing with chronic injuries makes it very difficult to find future careers. If we can take a scientific approach to training and conditioning that allows their bone to develop in a way to manage the stresses that are placed on them by racing, we're going to make significant progress, I think, in the retirement of racehorses in the future. So, without further ado, I'd like to introduce our speaker, our first speaker, which is Tim Parkin, who will be speaking about assisting veterinarians perform their roles. Tim's head of the Division of Equine Clinical Sciences at the University of Glasgow and has a long history of applying veterinary epidemiology to racing industries. He's been preeminent in that field, and I think you'll find his work and his insights fascinating. So I'll hand over to Tim.
Thank you very much for the invitation to come and speak at Asian Racing Conference. My first time at this conference, and thoroughly enjoyed it so far. I hope you will gain at least a little bit out of this session. As Brian said, we speak quite a lot at International Conference of Racing Analysts and Vets, but it's kind of unique to be able to speak to a different audience about some of the work that we do. I'm very much driven by data, evidence-based person, and the key messages that are going to come from my talk are very much around what we are able to do, and I think what we're on the verge of being able to do with data for racing regulators. So what I want the messages to get across are that models that we produce can be predictive. Prediction can aid decision making. And I think we're at the stage now with the speed of computing and the fact that we're so interconnected that essentially technological integration can make some of what we produce useful in real time, which I think is the key aspect that has been missing from a lot of the work that we've done in terms of turning it into useful information for the racing regulator to date. So I'm going to give a very potted one-slide history of 20 years of risk factor analysis. I'm going to talk about the goal that we have now, which is identification of the at-risk horse. Talk about the key steps in that goal, and then finally just summarize where I think we're going in the very near future with respect to equine welfare and veterinary regulation. So this is just a list of some of the outcomes that have been investigated, some of which we've investigated, other people in the same field have investigated just in a number of different racing jurisdictions around the world. Essentially what we've focused on, right back, I started my PhD 20 years ago, was focusing on the really serious outcomes for the racehorse and identifying risk factors for those serious outcomes. Now, obviously, thankfully, those outcomes are relatively rare. Unfortunately, that does create problems for us in terms of being able to predict those outcomes when they do occur, which I'll highlight in the next few slides. So there are many, many risk factors we've identified. I'm not going to go through those in any great detail. Some of them are modifiable, and you might say that we've had some impact. This is just an example of work. We've been working with the US Jockey Club since they started collecting equine injury data in 2008. And this is the rate or risk of fatal injury in North America per 1,000 starts since that period. And you can see that over that period, over the 9 years of data to date, we've seen a 19.5, 20% reduction in the risk of fatal injury in North America on the track. Now that equates to, if there were the same number of starts in 2017 as there had been in 2009, there's been a drop in the number of starts, but if there had been the same number of starts, then that would equate to 154 fewer horses dying on North American racetracks 2017 compared to 2009. Now, we're not claiming any particular credit for this, but I think the point is that we are now talking to the industry much more often. The fact that the industry is much more aware of those sort of issues. We go over to the Welfare Safety Summit on an annual basis whenever it's held annually. And I think we've helped to generate an attitudinal change towards equine welfare, particularly in racing in North America, that has generated regulatory change that probably have contributed to the change in risk that we've seen. I'm not going to get into any complexity in terms of the modeling or the statistical modeling that we do, but I want to demonstrate really the contrast between what we've previously done in identifying the risk factors and how easy, in quotes, that has been, compared to what we're now trying to do in terms of identifying the at-risk horse. So these are some hypothetical slides that I put together. And what I want you to imagine is that these are, you can't see the laser, but these are essentially 10 consecutive race days at the same track, going along the x-axis, so 1 to 10. Up the y-axis is the risk for each start, and each start made by a horse is represented by the blue dot. And it can be the risk of anything, risk of fatality, risk of fracture, risk of tendon injury, whatever it may be. Each horse start has a different level of risk, okay? And in this example here, we go from a 0 risk, which is probably unrealistic, to a risk that is 9-fold greater than the median. So our median risk level is set at 1, okay? So half of all starts are below that lower line. They're all piled on top of each other, but half of the data points, about 60 starts on any one day, would be below that line. What we want to identify is those horses that are significantly greater risk of ending up with the outcome that we're interested in than the average horse. So for this hypothetical situation, I've suggested we might be interested in identifying horses that are 5 times greater risk than the average horse. So that would represent all horses above that red line. So that's about, in this example, about 25, 30 different horse starts over these 10 days. Now, in order to identify which risk factors contribute to that elevated risk, we simply identify which horses hold that risk factor or are exposed to that risk factor. So one such risk factor might be racing with a new trainer, and there will be some horses in the lower risk level that are racing with a new trainer. But what you can see, and this is because the risk factors drive the risk, is that essentially those horses towards the top end are more likely to be racing with a new trainer. Similarly, horses that started their career as an older horse are more likely to be above the red line, and similarly, entire males are more likely to be above the red line. So our models take all of the individual risk factors that we identify and contribute to that y-axis risk. So they all contribute together, and you end up with an overall risk for an individual horse in a particular start. Now, the point is that that individual risk is unlikely to be exactly what the horse experiences, but it does allow us to rank the horses on a particular day in terms of their level of risk with respect to the particular outcome we're interested in. So that risk factor identification is relatively easy. We've done that many, many times over the last 20 years. Computing power and statistical techniques enable us to do that relatively easily, given sufficient statistical power from data that we're provided and sufficient outcomes of interest. What's much more difficult is the thing that Brian was talking about now in terms of being able to identify that one horse that is likely to end up with the fatal injury at the end of those 1,200 race starts over a 10-day period. And that is largely driven by the fact that, thankfully, equine fatality or fatal injury in a race is still relatively rare. So if we take it at, I don't know, 0.1%, so 1 in 1,000, and that's higher than some in racing jurisdictions, that's lower than some racing jurisdictions. But if we just take that number for convenience, and we have our 1,200 starts over those 10 days, essentially what we're aiming to do is identify that one horse over those 10 days that is going to end up fatally injured. And you can see that's extremely difficult. However, if we are able to accurately develop models that produce a predictive ability, that have a decent predictive ability, then at least for those horses that have 5-fold greater risk, then we have a 3% chance of identifying that horse individually. If we didn't have that model and if we had no clinical acumen, then our chances would be about 0.1%. But if we just focus on those top 25, 30 horses with the greatest risk, then our chance is about 3% of identifying that horse. Brian will tell me that's not particularly useful still, because obviously he's got a 1 in sort of 25 chance or 1 in 30 chance of actually identifying the correct horse. So that's still not particularly useful for Brian when he's trying to do his regulatory job at the Hong Kong Jockey Club. Why can't we be more predictive? Well, let's just give this a little bit of thought. This is kind of going back to a little bit of basic maths, and you'll understand why it's so difficult to do so. If the risk is approximately 0.1% of starts, in 10,000 starts, you're going to get 10 fatal injuries, and you're going to get 9,990 starts not ending in fatal injury. So if you had to guess if a start was going to end in fatal injury, you're always going to say no, because you're going to be correct 99.9% of the time. Our models work in the same way. What we're trying to do is improve on a very, very good null model that will always say, no, this start is not going to end in fatal injury. So that's one of the reasons we find it so difficult to provide information that is useful for the racing regulator today. So we thought a lot about this and how to make life a little bit easier for us. And we've talked about quantifying lifetime risk, season risk, or meet risk when a group of horses turn up to a racetrack, and actually you quantify the risk for all horses turning up at that meet and say, okay, what's the likelihood that X, Y, and Z will end up dead by the end of the meet? None of those are particularly useful, again, for the racing regulator who's having to look at the pre-race exams of those horses, looking at those horses trotting up, and they actually want to know what's the likelihood of the horse dying in the next day or two when it's going to be on the racetrack. They don't want to necessarily know that in 2 years' time that horse is going to end up dead because we've got a lifetime risk for it. So we've now come to the conclusion that actually changing the outcome variable is a much more sensible approach. And I'll demonstrate again with the same 1,200 starts why this is so much potentially more useful for the racing regulator. If we look at something like post-race lameness or unacceptable performance, the prevalence of which might be, let's say, in the region of 5%. And actually, this is a really useful outcome to identify, because a lot of the work we've done in the States, one of the key things we've identified is that horses with previous injury are significantly more likely to then, in subsequent starts, end up with a fatal injury. Even after they come back after a rehab period, their base level of risk never returns to the level that it was at prior to injury. So being able to identify these horses that end up with some sort of racing injury, post-race lameness, or unacceptable performance is nevertheless a very useful tool, because it's the precursor of the endpoint fatal injury or the retirement from racing. So again, let's think about the 1,200 starts that we've got from 10 race days and the risk, the same 1,200 starts there. And we add on to that the median risk and the 5-fold greater risk. Now, if we're looking at post-race lameness as our key indicator that we're trying to identify, we can now see that, yes, they're all shunted towards the top, as you'd expect, given that the models are reasonably predictive. Some of them are below the average risk. They end up with post-race lameness. So it's by no means that any model is going to be 100% predictive. But what it does say, if you count up those red dots above the red line, is that actually we now have a 50% chance of being able to identify horses that are likely to end up with post-race lameness at the end of a race with these particular data and this evidence-driven analysis. So if you focus on those horses that are at significantly greater risk, then you will be much more likely to identify those horses with post-race lameness. So it does become information which is much more useful to the veterinary regulator, the trainer, or the owner. And we believe information that can be genuinely used to help inform decision making. And the second half of this is the final couple of slides will talk about how we think that can happen. One thing I want to touch on is why data coverage is so important. And by data coverage, I mean multiple data platforms where data arrives from lots of different areas and talks to lots of different types. And there's some work we did a couple of years ago looking at trying to explain why we'd seen this significant drop in the risk of fatal injury in North America. And I think this is rather intuitive. There are lots of risk factors we've identified for fatal injury in North America on the racetrack, some of them given here. The size of the sphere or the disc indicates how important they are and their odds ratio and that sort of thing. But what we did was we looked at which of these risk factors had reduced in prevalence over the same time that the risk of fatal injury had reduced, and looked for correlations between the two. And we identified that there are about 6 different risk factors that reduced in prevalence over the same period. Surface condition, horse gender, so fewer entire males, fewer starts off dirt, age at first start, so more horses starting as 2-year-olds, fewer horses starting older, fewer horses changing trainer, so more horses spending more time with the same trainer, racing intensity, various different measures of how frequently horses were racing, and then race distance. And in particular in the States, that was a reduction in the number of races less than 6 furlongs. And the percentages there indicate how much of the reduction in risk over that period each of those risk factors contributed by the fact that it itself was reducing. Together, they contribute about 35%. Disappointingly for us, that obviously means that 65% we can't explain. We were unable to explain that significant drop in North American risk of fatal injury for 65% of the drop. And we hypothesized and we talked to the racing guys in North America, and clearly some of the things that came out are things that we don't have access to veterinary history for the data that we're crunching in North America. We have limited access to complete training records. We are now starting to analyze some of the pockets in North America, particularly California, for example, where we do have access to complete training regimens. There have been changes to medication and other regulations in the States that are likely to have had an impact on the risk. But at the time we did the analysis, the exact time point that those regulations were introduced into different tracks was not available to us. And there are other local modifications that will have undoubtedly had an impact at the individual track level. There are bound to be other potential measurable risk factors, and there will, of course, be some natural random variation. What I want to emphasize is that there is a need whenever we do this type of work, and I'm data hungry, I'm data famished, I need data. That's what we need to produce impactful models. the greater the number of data platforms we have available to us, and the greater the number of data sources we have available to us, then it is undoubtedly the case that the impact of the models we produce will be greater. In most analyses, we cover these areas here. So racing, racetrack, pedigree to some extent, and individual aspects of the horse. In some analyses, we also are able to include training regimens. But it's extremely rare. With some of the work that we did with Ken Lam in Hong Kong a few years ago is the exception to this. It's extremely rare that we're able to include veterinary or medical or health concerns of the horse or histories of the horse in any of the models we produce. And probably this is the biggest hole in the data that we have. It makes sense that we should be able to, that the factors that lead to fatal outcome or retirement are going to be very, very strongly related to the medical history of the horse. We know that, that's obvious. So the key steps to achieving this goal, well, one key step, simply data, again. We know that most racing jurisdictions will have plenty of information about starts and horses, plenty of information about history. Many now collect very good racing training injury outcomes. Relatively few have available to us around the world veterinary records or medical histories. Some have detailed training regimens. But what gives me pleasure talking to this audience is that actually most Asian racing jurisdictions do indeed cover the full panoply of data platforms. And some Asian racing jurisdictions genuinely have full access to veterinary records and medical histories. So I think in this particular part of the world, we have a real opportunity to lead and demonstrate that we can actually produce models that are genuinely going to aid the veterinary regulator on the ground. I want to just talk a little bit about how we think, final couple of slides, this can feed into veterinary regulation. It's all about communication, really. We need to be able to tell the vet, give the vet information about what the models are saying in terms of the risk for that individual horse. Each horse ends up with a risk profile, being it high or low or whatever that may be. And we don't see this as the solution to the problem. We see this as simply an extra piece of kit that goes into the vet's bag that can aid diagnosis or can help support clinical suspicion. If Brian is trotting up a horse and he has some clinical suspicion, thinking that horse might need to be pulled from the race or scratched from the race, if the models and the data are also saying that this horse is an extremely high-risk horse, maybe that will sway his decision one way. However, we don't think it stops there. We also think there's opportunity to talk to trainers and owners about which race to enter horses into, given particular risk profiles, and also indeed whether to retire horses from racing altogether, given a particular risk for that individual horse that's unlikely to change very much if they enter into different races. So final slide, how we think this could work on the ground, and indeed how this is potentially working. So the development of the models, and I should just say, I think the theme of the conference very neatly sums up this final slide in what we're trying to do. We are innovating in terms of producing predictive models. We need to collaborate because we don't have the data, the racing jurisdictions have the data, and I think together we can genuinely transform the risk of fatal injury or deleterious outcome on the racetrack for individual jurisdictions. Data would come to us, we would analyze the data, models would be built for whatever outcome we're particularly interested in for that particular racing jurisdiction, or multiple outcomes. Something that's very important to understand is that we would then validate those models. So if we were provided data from 2010 to 2017, we would leave the 2017 data alone, you'd develop the model on 2010 to 2016 data, and then test the 2017 data against the model. And essentially say, okay, let's assume we had the model in place at the beginning of 2017. How many of those horses that ended up with the outcome we were interested in actually were predicted to have ended up with the outcome we were interested in from the model we produced? So essentially you test the model, its prediction against what was actually observed. If you get a great big tick and actually you end up with a reasonably predictive model, that whole process can take anywhere between 3 to 6 months for a reasonably qualified statistician or coder. If you get a big tick, then you can start using that. We believe you can start using that information in real time. Race entries would come to us. We would run the data through the models. a risk profile for each race start would be provided for the OV, the veterinary regulator on the ground, and they would have that information available to them by the time they were doing the official veterinary checks prior to racing or prior to declarations. That whole process can take 24 hours. So I think that's how we see this model working. I think given the data-driven nature of what we do, the racing industry, I think there's an enormous amount of data that is currently underused, and I think we can make significant impact by using it more prolifically. Thank you very much.
Thank you very much, Tim, for an excellent and thought-provoking presentation. I may have been a little bit pessimistic at the start, but I do think we are now at a stage where the base is there for us to build on, and that we may, over the next few years, make some very significant progress in this area. Our next speaker is Chris Whitton. Chris leads the Equine Limb Injury Prevention Program at the University of Melbourne. I first met Chris when I was at Racing Victoria, and one thing I was particularly impressed about was the fact that this centre at the University of Melbourne is a multidisciplinary research program, and that it includes not just veterinarians, but it goes outside to medical research, to biomechanics, to engineering, epidemiology, microstructural analysis. And I think that's very important in making progress, is that we look outside our own world to what's happening in other areas that can be meaningfully applied to our situation. Chris has an excellent presentation. I think you should leave inspired and much enlightened by it. So thank you, Chris.
Thanks, Brian. And thank you for the opportunity to speak at this Asian Racing Conference. So I'm going to talk about our research program, and I'm going to talk about why leg injuries are important, our research goals, what we've found so far with our research program, and where we're going in the future with it. So limb injuries can be fatal, as we've heard about, and they are the most common cause of horse deaths on racetracks. The injury rate in Australia, the limb injury rate in Australia is about 0.32 per thousand starts, which doesn't sound like a lot, but that adds up to around 20 horses per year just in the Melbourne metropolitan area. And so it has a significant impact. Interestingly, there's a greater risk for horses in high-profile races for a number of reasons, and that has resulted in deaths being widely publicised when high-profile horses like Red Cadeau break down in big races in front of big audiences. And as we heard today, middle-class, urbanised people don't like to see horses dying on racetracks because welfare is really important to them. It's also important, as we've already heard at this conference, for jockey safety. Horse fatality is the most common cause of jockey injury, and when a horse breaks a leg and falls, the jockey injuries are more severe than just when they fall off for misfortune reasons. We also get non-fatal injuries, limb injuries, and these are less severe, but are in fact a lot more common. Around 30% of horses in the UK will suffer a fracture sometime in their career. And joint injuries like these ones in the surface of the fetlock joint occur in about 80% of horses in Hong Kong, and the rate of injury is very similar in Australia. And the consequences of these non-fatal injuries are poor performance and enforced rest, so that horses are not racing and training when they should be, and early retirement. And that's been the frustration for me as a veterinarian, having to deal with these horses that have to be retired because there's nothing more we can do for them. And it's what really got me into this research. And I hear a lot, hopefully less these days, and Brian emphasised this, that, oh, they're just an accident, there's nothing we can do about them. Well, it's not the case. We have a lot of evidence that they're not an accident. The injuries that we see in racehorses only occur in racehorses. We don't see them in other types of horses, and other types of horses are prone to accidents. So it's something about racing which is inducing these injuries. They don't take a bad step. They're often injured with no evidence that anything was going on. They haven't run into another horse. They weren't kicked. They're galloping and the limb breaks, and often they take the bad step after the limb breaks. And when we look at these fractures, and we get a lot of them coming through our post-mortem room, an example here being a humeral fracture, which is one of our more common fatal injuries. If we take a cross-section through that humeral fracture, we can see there's this fuzzy bone around the fracture site, and that's callus formation, which has taken at least a week and probably a fair bit longer to form. So this has been coming on for some time. We just weren't able to detect it. And then when we look at the sites that are prone to injury, we find that under the microscope, we find that there is a lot of microdamage. So these cracks you can see on the lower part of that image, we find microcracks are present at these sites typically. And finally, when we look at risk factors, as Tim does, we see that accumulation of training miles at high speed is a risk factor. So if we repeatedly load any material, it will get damage. It's a law of physics, and bone is no different, it's no exception. If we repeatedly load it with high loads, it will sustain damage. That's called material fatigue, and it's a well-known phenomenon in all materials, particularly in metals. And there's an example of metal fatigue, a piece of machinery that's been undergoing cyclical loading and has developed these microcracks, these crisscrossing microcracks that you can see, one major crack through it, and that piece of metal has eventually failed. Well, this is horse bone with exactly the same appearance under the microscope, crisscrossing microcracks and a major crack through it. So horse bone is just like any other material. We apply enough load to it, it will eventually fail. And then the question is, are they preventable? Well, they develop over time, as we've said, so there is the opportunity for intervention if we can just be clever enough to know what's going on. We get accumulation of damage, so if we can reduce the rate of damage accumulation over time and increase the rate of repair, which I'll talk about a little bit later, we have the opportunity to reduce the accumulation of damage. And because they all have a common cause, they're all due to this cyclical loading, we have the opportunity to focus our preventative methods on the one area and have outcomes that influence all injuries. So the answer to the question is, are they preventable, is yes. I don't think it's easy, as Brian has pointed out. I think it is extremely challenging, but there is an opportunity there if we can only get clever enough to be able to achieve that. So our research program, as Brian pointed out, is multidisciplinary. We have veterinary specialists who understand the injuries, how they occur, who can identify them and can treat them. We have bone biologists who understand how bone responds to loading. We have epidemiologists which can number crunch, take all the data that we produce and do the analysis on it. We have mechanical engineers, which is really important because veterinarians and biologists don't understand mechanical engineering, as I've found out through our program, and they understand how substances are loaded, how they fail under loading. And then finally, we're using mathematics to bring all these things together to try and build models to understand how fracture is occurring. And the aim of the program is to develop training, management, and regulatory strategies that reduce career-limiting musculoskeletal injuries and catastrophic musculoskeletal injuries, and in the end, improve longevity and performance of racehorses. So what have we found? Well, if we repeatedly apply load, weight-bearing load, the typical loads that horses apply to their bone, and that's a piece of bone in one of our loading machines, we're applying the load that horses apply when they're galloping. If we do that repeatedly, we get failure. And we can graph the numbers, the load on the y-axis against the numbers of cycles that it takes before the bone fails. And at low loads, we have lots of cycles that the bone can sustain before it fails. But at high loads, it's only a few cycles before the bone fails. And in horses, load equates to speed. The faster the horse goes, the greater the loads it produces. Therefore, the fewer numbers of strides that it can sustain before failure occurs. And horses generate very large loads in their limbs. Now, you don't have to be a biomechanist to know that an animal that weighs half a tonne and goes at 70 kilometres an hour produces big loads. But when you actually measure them, it turns out they're far greater than we ever expected. So we can do this with our biomechanics people. So we collect information about how the horse moves, and here's an example of a horse walking, trotting, and cantering on a treadmill. It's got markers on it that we capture the movement with high-speed cameras, and it's also got a force shoe on its foot that allows us to capture the load. We then take that and build computational models, and we've developed the most sophisticated computational model of the horse's forelimb to date. And with that, we can we can calculate the internal loads created during exercise in all the joints and all the tendons. And it turns out they're really big. So even at the walk, a horse is generating in its fetlock joint a load that is greater than its own body weight. At a moderate gallop, not even a fast gallop, a moderate gallop, it's producing 4 tons in a joint that's smaller than my knee. And I've got skinny legs, and so I've got small joints. That equates to 3 small cars with every single stride. So if we take bone and then we apply the load that we know is being applied in the joint, you can see that what we think is a rigid structure like bone is actually deforming. My apologies, that's not replaying. See if I can do it again for you, because it's important. Not going to work. So when we apply to the joint surface, we've got the cartilage on top, the joint surface, the bone surface below. We actually get quite a lot of compression of that bone when we applied the loads that we know are being applied. And so when we get this deformation, the site at which we get the deformation, which is just under the cartilage, is exactly the site where we see damage. So you can see the microcracks forming immediately under the articular cartilage in the joint surface. And we've shown that over a horse's career, they actually accumulate damage. So the older the horse, the more damage it accumulates in its joints. We've got the bone on the top, which only has 1 crack in it, down to the bone on the bottom, which has multiple cracks in an older horse. So that means that the rate of accumulation of damage is greater than the rate of damage removal. And the interesting thing is that bone is able to remove the damage that accumulates. So and this occurs through the process of bone repair, which is done by the large cells that are in the bone. So the orange cells that I've got in that diagram there are the ones that remove the bone. The smaller blue cells on the left are the ones that produce new bone. And if you've got an area of microcracks, so the red lines on the diagram, as those cells remove that and the bone gets replaced, you're getting bone turnover and bone renewal. That's a physiological process that's going on in you and me right now, happening all the time. The problem we have in racehorses, and that's just an example there of it happening in the subchondral bone of a horse, damage at the bottom, the dark areas are where the bone is being chewed away by the cells, and so you've got a lot of surface area being formed where the cells are acting, and you can see the slightly darker bone at the top, which is the new bone being produced to replace the damaged bone. The problem we have in the racehorse is that when we're training horses and we've got them under intense loading, that process actually slows down. So, example there of a training horse at the top, there's not much bone surface there for the cells to be acting on because they're very inactive, not much bone removal going on. And this is the thing that struck us most when we started looking at this bone firstly. The training horses are very inactive. When we look at a horse that's resting, the bone on the bottom, you can see now there's a lot of surface area where the cells are actively removing bone, and there's small areas of dark bone where new bone is being produced. So training horses actually have very little bone turnover, whereas when we turn horses out to rest, that increases. So because we have this accumulation of bone damage over time, what we're seeing is damage accumulated when the horse is in training. The horse goes out for a rest period, and we get some reduction in that, but it's not totally reduced, and when it comes back into work, it increases again, as we can see on the graph. The simple way to resolve this issue and to stop the damage accumulation is to increase the amount of time the horses are resting, and that will then allow more bone turnover, hopefully keep the micro damage level at a stable and sustainable level. This is unsustainable because over time we're accumulating more and more damage. This is more sustainable. So where are we going with our research? We're trying to better understand the fatigue process because it is complex. And so we're testing a lot more bones under fatigue loading to try and understand the behavior of the bone. And this will allow us to work out how to train horses efficiently so that we can apply the load to their bone and minimize the risk of damage. We're also using our computational model of the forelimb to try and understand how different surfaces on tracks, different race track surfaces affect the loading in the bone. And that's work that's ongoing at the moment. So we can have evidence-based track design. If we can design tracks that minimize the loads in the limb, we can design safer tracks. Unfortunately, tracks at the moment are based on trial and error. You change something, you see whether you get injury. With our models, we'll be able to change something in the track and see what effect it has directly on the loads in the limb in real time. And we can give advice on what is the best way to design tracks that are going to minimize injury rates. We're also, as I said, using mathematical modeling to bring everything together, the biological processes, the mechanical processes, and the gait data to try and understand how injury occurs. This graph is from our first modeling effort showing how bone volume changes in response to different training loads. And we're trying to develop that further to try and predict what it is that causes injury, and then we can use that in individual animals or individual training programs to assess whether they're safe or not safe, and we can adjust things to see whether that improves the outcomes. And then finally, one of the real issues we have is detecting microdamage. The only way I can detect microdamage is in the laboratory under the microscope. Trying to detect it in the live horse is extraordinarily difficult, but we're trying to develop ways of doing that using things like inertial sensors like we have on this horse and monitoring blood levels of various markers to try and understand whether we can see microdamage development before it occurs. So musculoskeletal injury is a very important problem for the industry. Horses dying on racetracks in particular is not good for the public perception of the industry, and the underlying rate of injury is also a problem for performance of horses and early retirement. Onset over time of these injuries means that we have potential to prevent them, and that's what we're working on. And research to determine safe training methods, I think, is essential because it's the training that's producing the problems, and so we need to get smarter and learn how we can do it so that we're not creating injuries. And finally, I just need to acknowledge I'm funded by the Victorian State Government, Racing Victoria, and the University of Melbourne. Thank you.
Thank you, Chris. An excellent presentation. I think it's really, really important that the work, the information that Chris is providing the industry is communicated effectively to virtually all participants. Understanding how bone responds to training and stress is going to be fundamental to us achieving better outcomes. And while things are pretty good, we still look at perhaps 20 fatalities in the Melbourne metropolitan area, and that in this day and age is going to be harder and harder to justify to society. So it's very, very important work, and very important that the industry supports that work. Our next speaker is HeeEun Song, who is manager of the Equine Medical Centre here for the KRA. Olivia, as I know her, has spent time at Racing Victoria and also at the Hong Kong Jockey Club. And we're going to hear today how the KRA is implementing regulation and attempting to improve the safety and welfare of racehorses in Korea. So, Olivia.
Thank you.
Thank you.
Hello, I'm Dr. HeeEun Song of Equine Medical Center of Korea. First of all, I'd like to thank the organizing committee of AIC to giving me a chance to provide this presentation. It is a great honor to attend this AIC as a speaker. Today, I'm going to tell you about Veterinary Regulation of KRA. I know you might be tired, but if you can bear with me just for another 15 minutes, I'm going to be very appreciated. It won't be long. So let's get started. This is what I'm going to talk about. There are 3 race courses in Korea. In Seoul Race Course, the veterinary department consisted of, 초록색 눌렀는데 이거 눌렀는데 그래요? 그러면 다시 앞으로 해야 되고요. 이제는 넘어갔는데 괜찮아요. Sorry, start again. This is what I'm going to talk about. And yeah. In Korea, there are 3 race courses. And so in Busan, it's conducting the thoroughbred racing. In Seoul Race Course, the veterinary department is consisted of these teams and working as the headquarter of whole race course. And so I'm going to present the veterinary regulation focus on Seoul Race Course. So you can see what we do during the international racing season in quarantine stable. So we all get together to talk over the horses ready, or we always check about all of the horses. So I sorted out what we do related to veterinary regulation in this diagram. And on race days, pre-race and post-race, we all do the same thing as yours. And we also provide all-in-one service of diagnosis and treatment for horses injured in race days. So on non-race days, pre-declaration vet exam is one of our key roles of monitoring horses. And we recently adopted the out-of-competition testing, which is OOCT recently, with the international agreement. So I will talk about more details on next slides. So on race day in Korea, all horses are going to required to get pre-race chart-up test before the race on soft tissue because of horses' safety. And if the regulatory vet finds the abnormality, the horse will be withdrawn from the race after the additional tests. And the diagnosis result should be announced to the public because the public takes the condition of the horses very seriously. Yeah, this is the 5-year statistics of withdrawal horses. On average, 78 horses were withdrawn from the race out of 12,378 starts, and from that, 60 horses were withdrawn from veterinary issues like lameness. When you have to withdraw horses from the race, you can see the photo. It is really not easy to explain why we withdraw the horses to the people who are really related to horses, because our decision is directly related to their profit and reputation. So it is important that we should not be emotionally involved in this process and explain that they should have a long-term view of their horses. I think this is a universal issue. Don't you think? Do you have any idea of this? Then let me know after this presentation, please. And after the race, all horses are required to get post-race vet exam on soft surface. Right after that, focus on lameness, exercise-induced pulmonary hemorrhage, and poor performance. In Korea, stand-down period will be given to some horses depending on the diagnostic results, and that result should be announced to the public on our website. This is the 5-year statistics of EIPH occurrence on race day. So from this data, 54 horses got EIPH out of 12,378 runners on average. And 2 horses, as you see, 2 horses had to retire from the race because they had 3 episodes of EIPH within 2 years. As I mentioned before, we have stand-down period to protect horses and integrity of the race. If there are any problems or injured found related to the racing, the horse will be imposed month of stand-down period, and the horse should pass the pre-declaration veterinary exam and or barrier trial in order to return the race. Even though this is for horses' welfare and for the interest of people who are in this industry, there is a strong resistance since it can be accepted as a penalty for them. We also have a rule of medication named 10-day rule. We adopted this to control the medication strictly in the past, but now we think this is the matter of welfare to protect horses not to run the race when in treatment. In the International Conference of Racing Analysts and Veterinarians in Dubai this year, there were some surveys results on the presentation of survey results on medication control, especially with NSAIDs, steroids, and antibiotics overuse. Through the presentation, I thought that medication control is a common issue worldwide, and that our system can be considered as reasonable rather than just strict. As I mentioned before, pre-declaration exam is one of our key roles in monitoring the horses. Some horses appointed by KRA vets have to be tested before the declaration, focus on gait analysis. And we are trying to expand its horizon to cardiopulmonary function. So I think it's quite similar to Hong Kong Jockey Club's OVE system and Singapore Top Club system. On race day, we collect test samples from all horses before the race for screening, and the results come out before the start. There are some concerns about horses' welfare and safety, so we are working to minimize it. After the race, up to third place horses, and horses appointed by stewards, such as beaten horses, they should be tested in the sampling area. So, to provide our veterinary regulator service in KRA, we have these things. So, all these are interwoven and highly connected to each other. To give you a rough idea, I divided this into 4 different categories. So I'll go over one by one. Adapting the global standards. We have been hosting the international races for a couple of years, which has been very successful. And I took study tour to 3 different countries, Australia, Hong Kong, and Singapore, which was very valuable. I got a valuable knowledge, and it was very opening experience for me. And we got involved in the international activities such as attending an ICRAF, IMHC, and of course this ARC. So we are incorporating global standards such as international screening limits. Move to the next one, improving equine welfare. We recently adopted total care system this year, which means taking care of horses from A to Z in terms of their career. So we are also carrying out educational sessions for people related to horses because we have to protect them to safeguard people. And we want also with severely injured horses related to race. Sometimes it's not easy to financially commit to treatment for some owners because it can be quite expensive for them. So we support their treatment financially so that the horse can recover as soon as possible and minimize their pain and their further injury. Strong and fair regulation is really important. Korea is known as a country who has strict medication control, and many are agreeing that this is a reasonable policy for the benefit and welfare of horses. Transparency and impartiality can be basis for the building trust, and building trust can be the basis for cooperation with all parties involved. So we are trying to be transparent in everything like data, lab results, medical results. So this is one of the reasons why we put some horses record on our website. To be impartial, we explain why things have to be done that way in detail. They can see that we are not we are not trying to take sides of anybody through that. So to be transparent and impartial, we need some clear and straightforward data when it comes to the regulation. Sorry. So we have been looking into the sports medicine. So excuse me. In more efficient ways, using portable devices like Lameness locator to provide more objective results to people, as Dr. Chris Whitton showed me previously. So we can provide the objective result to people easily, though not disputable. We can also incorporate newly developed analytical and diagnostic techniques to get accurate results. Doing so, we can pick up every trace of medication. So that is why we are incorporating ISL, the international screen limit. Through the exchange program, we work along with international experts. So that goes with the first slide, hand in hand. I gave you a very short presentation about KRA, just to give you an idea how we provide veterinary regulatory service. We do not have much time to talk about, but so please, I hope you guys know how we work about that. This is what I have been doing and how we are doing. So I want to wrap up this session by saying this. There is no one absolute set of rules in veterinary regulation, but we can learn from each other, and people learn from try and error. So that way we can improve the standards of regulatory service. We as vets want to contribute so that KRA can move up to the next level, and we can have utmost high standards when it comes to the regulation. We are ready to embark on the next journey. Thank you for listening.
Thank you very much, Olivia. It's a very interesting and provided a really good insight into the challenges we face. There's the pre-race veterinary inspections, the suitability to race inspections, the controversy that may arise from these inspections when you're telling somebody their horse is not in a suitable condition to participate in a race, and the trainer and the owner are absolutely convinced that it is in good condition, inevitably there will be conflict and controversy. And when it comes down to that's my opinion, and somebody has to make that decision. But if there is something science can help us with in terms of justifying, of identifying those at-risk horses, of providing that evidence to support the decision making initially before the decision and then justifying it afterwards, it would certainly make our life a lot easier. Other things are about stand-down periods. How do we scientifically justify what those stand-down periods should be? That especially applies to bleeder stand-downs. There's no question they're essential, but what's the science behind the time periods that are applied? I think there's still quite a bit of work perhaps that needs to be done on that. Stand-down periods after an injury, should we have, stand-down periods before a horse can return to training to give it sufficient time to recover properly? I think we probably should, but how do we enforce that and how do we justify that to the participants? Again, science might help us answer some of those questions. So I really do think we're on the verge of being able to answer some of those questions and to provide a more scientific approach. There will be another session in the welfare session tomorrow about the application of technology to monitoring equine athletes that will complement this session very well, and I'd urge you to attend that. But for now, if you could join me in thanking the speakers, and we'll close the session. Thank you very much.
Brian, thank you very much indeed. And as you say, tomorrow the first session will complement this one. It'll be about equine welfare. Then we'll return to integrity and look at anti-illegal betting and money laundering before some industry profiles and finishing with racetrack management and safety. So, Brian, you did it already. I'd like to thank the panel to tell you that the Korea Cultural Night tonight is available to everybody. The buses will leave conference hotels at 5:30, so not much time to get back there, and you can change because smart casual is the dress code. But please do bring your conference badges. Later in the evening, you'll have a chance to walk around a night market as well. Thank you for attending today, and thank you to you panelists. Thanks, Brian.